Hi, everybody. I just wanted to talk about contrast agents. And I want to talk about the only type of contrast agent that is suitable for IV injection. And that would be a water-soluble iodine contrast. So water-soluble iodine contrast. So I'm going to write that right here. Water-soluble iodine contrast is the only, type of contrast suitable for IV injection. Okay, sorry, I'm not the best typist. Okay, so notice this says iodine, water soluble iodine. That's the only type that's suitable. Now, because iodine by itself is toxic to the human body, it's actually attached to a benzene ring to make it non-toxic to our body. So what I want to say is water-soluble iodine can come in two forms. It can be ionic. Okay, ionic iodine contrast, or it can be non-ionic iodine contrast. So what does that mean? If something is ionic iodine contrast, that means you have the water-soluble molecule, and what happens is in blood, it starts to dissociate with each other and it forms ionic molecules in the body, charged particles. So instead of having one molecule that's together, so let me see if I can draw a picture. Let me see, wait a second here. Let's see if I can do this. Okay, instead of having one molecule, let's say that's together. So this is let's see. Let's say this is the molecule. I'm not doing too good with my drawing. Let's say this is the molecule. Okay, so this is ionic iodine contrast on the molecule. This is the molecule. It would stay together, as opposed, so it stays together here, and then what happens is when it gets into blood, it'll dissociate. So that means you'll get different, the molecule will break up into the blood and you'll get charged particles. And because there's different charged particles in the blood, it's more toxic for the body. If you get something that's non-ionic iodine, then this molecule, when it goes into blood, okay, let's just say this is the molecule. When it goes into blood, it does not dissociate. So it stays intact. So it does not form various charged particles in blood. So because it stays together and it doesn't dissociate to form charged particles in the body, it's less toxic. So non-ionic iodine is less toxic. When you're talking about osmolarity, that all that word means is osmolarity is how many particles are in blood. So because this stays intact, the non-ionic stays intact and doesn't dissociate, then it's less osmolarity in the blood because it doesn't break up. So it's less osmolarity and it does not add to the concentration to blood. It stays, the blood level to concentration level will stay similar, as opposed to ionic, where you see how this breaks up. So that means it's high osmolarity because we will get a lot more substance in the blood and it will be very toxic to the body because the osmolarity, the normal osmolarity that we have, which contains the blood, to the osmolarity when we have the contrast is going to be vastly different. So it's more toxic to the body. So ultimately, or what we would really like to have is a non-ionic iodine contrast, which is the less toxic to the body, and it has the lower osmolarity. So I hope that helps. Thank you.